Hi dear, hope you are fine, and I am here to explain you the Gibbs free energy from the first law of thermodynamics and second law of thermodynamics. Let's start our lecture, and we know that the first law of thermodynamics is equal to the internal energy of the system is equal to the heat produced in the system and the work done minus the work done in the system. So if we take the change in this internal energy, how we can write it? We can write it du means that change in internal energy. Change in internal energy will produce the change in heat energy minus will sign that it will deduct or it will reduce will dw means change in work done. And we know that it is the first law of thermodynamics. First law of thermodynamics explain that that internal energy of the system is equal to the heat of the system minus the work done of the system. And second law tell us the entropy of the system. Entropy, what is entropy? Entropy, it is the randomness of the molecules in the system. And how we can write it? ds equal to dq mean that heat produced divided by temperature. I will explain you how it is. ds is equal to dq over dt. So we have a system ds delta s mean this is surrounding, so with subscript sor mean that it is surrounding system, and it is without subscript it means that it is system. The entropy of the surrounding and the entropy and the change in entropy of the system greater than zero. And we know that the entropy of the system is equal to the q over t. This is ideal case, but we can't see in our daily life. And if we take as surrounding delta s, we write it as SOR. It means that it is surrounding. With q, SOR means that the heat in the surrounding with temperature. If I will explain you that if in one side we have a surrounding and the other side we have a system, and the heat energy is transferred from the surrounding to system, then this heat will automatically reduce, and we take it minus q. It means that heat energy transferred from the surrounding to system, and it will plus because this energy is added to the system. So we can write it as heat of the surrounding is equal to the minus q that it without the subscription it means that it is the heat of the system. And here I tell you that change in entropy of the surrounding is equal to the minus q, mean that if the heat energy is transferred from the surrounding to system, the a minus sign will show that. And the temperature is divided. This is the second law, which I write it here. I explain it to you. Then again is the third step is of our explanation is combined first and second law. The combined first and second law, and we know that this is our first law and this is our second law. We have to combine these both of law. First addition of this law, I will explain you what is work done. Work done is equal to product of pressure and volume, but in our case pressure is constant in this system. Then work is p, pressure constant, change in volume dv. And from second law of thermodynamics, dq is equal to tds. Where I found this dq? If I find it, dq is this t which is divided here, it will multiply there, it will tds. dq is equal to tds. Then we know that du here, du is equal to dq minus dw. Du is the internal energy of the system change into minus dq here we take dq is equal to tds. We will put tds in the instead of dq. This is tds minus dw, and we know that dw is equal to pdv. Then we put pdv in the place of dw. Here I put it pdw. Okay, I hope that you will enjoy this tutorial and learn it from. Then du, and we take a t is equal to our partial u over partial s with volume constant. This is our t. And p is partial u over partial v with temperature constant. S shows that it is temperature. Here we put the values of t. T is equal to partial u over partial s with volume constant, and ds as it is minus p is equal to partial u over, we place this value into this place, partial u over partial v over s dv. Then we know that enthalpy is equal to the sum of the internal energy of the system and work done of the system. Here I write it, enthalpy of the system is equal to the internal energy multiply the work done. Work done, we know that work done is equal to the product of pressure and volume. If we apply change in energy, dh shows that it is the change in enthalpy, and du change in internal energy, plus PV change. How we write it? PV, it is the here we apply the product rule of the differential equation derivative. First is first thing as it is, and the derivative of the second plus, and second thing as it is, and the derivative of the second dp. Hey, the next step is, if we apply the dh is the change in enthalpy is equal to tds minus pdv. Here du is equal to tds minus pdv. I write the values of tds minus pdv here. Here I write the values of this, plus pdv plus vdp. Where I found it? Here. I put the values of du, which is equal to the tds minus pdv, and also I put the values of pdv plus vdp. This is dh equal to tds minus plus vdp. How it is pdv and plus pdv. It is minus sign, it is plus sign. We can also cancel, and we have tds plus vdp. Enthalpy of the system is equal to tds plus vdp. And if we talk about the Gibbs free energy, it is equal to the Gibbs free energy equal to enthalpy of the system plus product of temperature and entropy of the system. If we apply the change in Gibbs free energy dq, it is the change in enthalpy plus minus sign with, then we are also applying a product rule of the derivative. What it is the product derivative product rule? It shows that we take first value as it is, and we take the derivative of the second thing plus sign. Then the second thing as it is, we take derivative of the second thing, first thing is it. And dh, we did know that the dh value is equal to, how it is, th equal to, here dh is equal to tds plus vdp. We put the values of dh here, tds plus vdp minus sdt. This is, we take the minus value here, minus sdp plus tds. Here tds is in plus, and this tds is in minus. We cancel it, and we have a vdp minus sdt. This is the Gibbs free energy of the system. dg, change in Gibbs energy, equal to the volume with the change in pressure minus entropy of the system and change in temperature. This is success with pressure and temperature. I hope this is my first as a practice, and I send you as a proof. This my first tutorial. I hope you will enjoy it, and you will give me a good response. I will also send it the this pdf to you. You will get knowledge, and if you don't understand anything, you can easily explain or easily ask from me. I will available to you for this. Okay, thank you so much.